All right, here we are. A few pieces we're going to do together, the remainder theorem, the factor theorem, and then we're going to divide using synthetic substitution. A little bit later on, we'll get to dividing with polynomial long division. In case you don't remember that, we will go over an example of that at the end of the videos. It'll be the last one. But the remainder theorem. So it says when a polynomial p of x, so a polynomial function, is divided by x minus a, the remainder is going to be that function um, with a plugged in. So the remainder is p of a. Now the factor theorem says that for a polynomial function, p of x, x minus a is a factor if and only if p of a equals 0. So in other words, that when you divided by x minus a, the remainder, because remember p of a was equal to the remainder, and that the remainder had to be 0. And this should make sense to you, kind of if we take a little bit slightly different look at it. Think of the number 12, okay? And back in 4th grade or whenever it was that you started learning about division, you learned about the factors of numbers as well. And so, for example, one of the factors of 12 is 4. And 4 goes into 12 3 times, and so you'd have 3 times 12 and get 12, and here's our long division. So 12 minus 12 gives you 0. So 3 remainder 0. That meant that since 4 went in evenly with no remainder, that it was a factor. All right, and that's you're familiar with that. Now, if we had 5, is 5 going to be a factor? And hopefully Shane will know, and here's why. So 5 goes into 12 twice. 2 times 5 is 10. We subtract out that 10, and we're left with a remainder of 2. And maybe it's been a while since you actually dealt with remainders, because now we would typically use decimals and keep on going there. But right now we're just going to look at our remainder and ending there in the division process. So here we go. Let's use these two theorems. So before we get to the third problem of actually dividing by synthetic division, let's take a look over here. And I wrote out a function for us that hopefully we'd be able to factor pretty easily, just to help us out, use something we know already and see how that's going to work. So we know that this factors out to x plus 1 times x minus 1. Okay, that's the difference of squares, and here we are. So, oops. Now, using synthetic division, we would take the coefficients here, and so we've got 1 times x squared and the 0 times x. Remember, there's a plus 0x term kind of in here. Our b value just is 0 there, and then minus 1. So we took the coefficients. This is how we're going to do synthetic long division, and then let's divide it by x plus 1. So if we do x plus 1, the root of that, remember it's written as x minus a, so our a value is actually negative 1. That would be our root. And when we're doing synthetic division, we use the root. So negative 1, and here we go. So for synthetic division, bring the first number straight down, don't do anything to it. So 1 comes on down. And then we multiply it by our a value. So negative 1 times 1 is negative 1. And then again, we add. So 0 times negative 1 is negative 1. Now we multiply that by our a value. So negative 1 times negative 1 is positive 1. And negative 1 plus 1 is 0. That's our remainder. So we have a remainder of 0, meaning that x plus 1 is a factor. That was what we just divided out. And so if you wanted to write that kind of in a, we divided x plus 2, or x squared minus 1 divided by that x plus 1, and we ended up with our quotient here was, it should be x minus 1. Let's see if it in fact is. Remember, this is 1x squared plus 0x minus 1, and we just divided out x plus 1, so these our degree dropped by 1, so this is 1x minus 1. Hey, that is what we have over here. All right, now let's do that same process again, but divide by something that isn't going to be a factor, just to see if we can kind of show ourselves what the remainder and factor theorems kind of mean here. So if we took x squared minus 1, so again 1, 0, negative 1, but this time let's divide by x minus 2. So our a value would be 2. And what those two theorems just said is that as we divide these out, the remainder should be whatever the function is with that a value plugged in. And the remainder should only be 0 if it's a factor. We know this is not a factor, so let's go through and make sure everything happens as it's supposed to. So 1 comes on down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. And negative 1 plus 4 is 3. So it did not go in evenly. We have a remainder of 3. Now remember, this was the function. That means when we plug in our a value of 2, we should get the f of 2 is 3. It should be equal to the remainder. Now let's see if it actually is. So if I have 2 squared minus 1, I get 4 minus 1, which gives me 3. And so f of 2 was 3. All right, everything's on track. We're doing well. Let's use synthetic division here on this problem as well, just to get some more practice with it. So x cubed, so that's a 1, taking just the coefficients 1, 5, 5, and negative 2. I'm making sure that all of my degrees are here, that there's no coefficients of 0 that maybe have taken a term out, because we would need to include those back in if there was. But we've got 1, 5, 5, and negative 2. And just kind of in our heads, remember this means x cubed, x squared, x, and x to the 0 if you really wanted to have that x to the 0 term there. Now we're going to divide that using synthetic division. We're going to divide x plus 2. And when we divide using synthetic division, we use the root. We use that a value when it's x minus a. And so really our root here is negative 2. That's the number we're going to use to divide. All right, 1 comes on down. 1 times negative 2 is negative 2. That adds to give us 3. Negative 2 times 3 is negative 6. 5 plus negative 6 is negative 1. And negative 2 times negative 1 is positive 2. And that adds up to give us 0. So it did go in evenly, meaning that x plus 2 is a factor. Actually, let me write out that as a factor. So p of x is going to be equal to the term we just factored out, so x plus 2, times whatever our quotient is. And so let's see what the quotient is. Remember, we started with x cubed. We divided out x plus 2, so these are going to drop down a degree. So that's 1x squared plus, it's a positive 3, so plus 3x minus 1. And so that's x squared plus 3x minus 1. And you'll use synthetic division to help yourself factor quite a bit, especially as we get into some of the things, just some stuff later on. Well, actually, I'll save that for then. But there we go, using synthetic division, our remainder theorem and factor theorem. Hope that helped.